Hi guys, hope you're doing well. In this video I'm going to discuss about projection of solids. Hoping that you're already well aware of projection of lines and projection of planes, I'm going to directly discuss about projection of solids. In this video I'm going to discuss about introduction to solids, classification of solids, resting condition of solids, and I'm going to take up few problems on pyramid. Definition. A solid is a three-dimensional object having length, breadth and thickness bounded by surfaces which may be either a plane or curved or combination of two. Some of the examples for a solid or a 3D objects are a cylinder, hexagonal prism and combination of plane and curved surface. If you look into the cylinder, it is a 3D object which is bounded by a curved surface. And if you look into the hexagonal prism, it is a 3D object bounded by a plane surface. And if you look into the next sketch, it is a 3D object which is bounded by combination of both plane and a curved surfaces. So these are some of the examples for a 3D objects or a solid. Solids are classified into two groups. One is polyhedra and solids of revolution. A polyhedra is defined as a solid bounded by a plane surfaces, or you can also call it as a faces. Okay, a polyhedra is a one which is surrounded by only a plane surfaces. There is no curved surfaces. Okay, that is called as a polyhedra. Polyhedra may be of three types. One is regular polyhedra, prisms and pyramids. Then a polyhedra is said to be regular if its surfaces are regular polygons. Regular polygons like triangle, pentagon, square or hexagon. Okay, a polyhedra is said to be regular if its surfaces are of a regular polygons. The following are some of the regular polyhedra. One is tetrahedron, cube or hexahedron or octahedron. We call all these solids as a regular polyhedra because if you look into the tetrahedra, it is made by four equilateral triangles. Okay, all the four faces are of equilateral triangle. Hence, it is a regular polyhedra. Then, if you look into cube, it is made up of 6 equal square faces. The same square faces. Hence, it is called as a regular polyhedra. Then, if you look into octahedron, it is surrounded by 8 equilateral triangles. Hence, it is also called as a regular polyhedra. Then, coming to the next type of polyhedra, it's a prism. A prism is a polyhedra formed by two equal parallel regular polygonal end faces connected by side faces which are rectangular in shape. If you look into this sketch, it's a triangular prism which is formed by two equal parallel regular polygonal end faces. Here, these are the two equal polygonal end faces, that is triangle. Okay, the two faces, one is the top face and the bottom face, and surrounded by a rectangular face. That type of solid is called as a prism. If it is a square prism, then the top and bottom faces will be a square polygon. If it is a pentagonal prism, then top and bottom face will be a what? A pentagonal lamina. Okay, and an imaginary line passing through the center of the two end faces is called as the axis of the prism. Here you can observe the imaginary line passing through the center of the two faces. It is called as the axis of the prism. The other different types of prisms are a square prism, pentagonal prism and hexagonal prism. The next type of polyhedra is a pyramid. A pyramid is a polyhedra having only one base with a triangular faces meeting at a point called apex. And here also the imaginary line passing through the center of the base and the apex is called as the axis of the pyramid. If you look into the sketch, it's an example of a pyramid. That's a triangular pyramid. The base is of what? triangular in shape, and it is surrounded by a triangular faces, and all these triangular faces meet at a point called as a apex. This point is called as apex, and the imaginary line passing from apex to the center of the base, we call it as a axis. And the different types of pyramids are, as seen in the figure, it is a triangular pyramid, then square pyramid. If the base of a pyramid is square lamina, okay, or square polygon, then it is called as a square pyramid. Then pentagonal pyramid. If the base of the pyramid is a pentagonal lamina, then it is said to be a pentagonal pyramid. If the base is in hexagon shape, then it is said to be a hexagonal pyramid. Then solids of revolution. If a plane surface is revolved about one of its edges, the solid generated is called as solids of revolution. The examples are cylinder, cone and sphere. If you look into this sketch, the examples for solids of revolution are cylinder, cone and sphere. They are generated by revolving one of the edges of a plane surface. If you look into the cylinder, it is obtained by revolving a plane surface, that is a rectangular plane surface, about one of its edge. That is, by revolving this rectangular plane surface about the edge OP for 360 degree, you are going to obtain a cylinder. Likewise, if you revolve this right angled triangle about its edge OP for 360 degree, you are going to obtain cone. Similarly, if you revolve the hemisphere about the edge AB for 360 degree, then you are going to obtain the sphere. So these are the solids of revolution. And the position of solid with respect to the reference plane. The position of solid in space may be specified by the location of either the axis or a base or a edge, diagonal or a face with principal plane of projection. The following are the position of a solid that can be considered. One is the axis perpendicular to one principal plane, that is axis perpendicular to HP and parallel to VP, or axis perpendicular to VP and parallel to HP. The next condition is axis parallel to both HP and VP, and then axis inclined to one principal plane and parallel to other, and the next condition is axis inclined to both the principal plane. So this is the condition in which we are going to solve most of the problems. The position of solid with reference to principal plane may also be grouped as follows. The solid may be grouped as solid resting on base, solid resting on any one of its face or edge of a face or edge of a base or generator or slant edges, etc. And one more condition is solid suspended freely from one of its corner, but here we will be dealing with only the first two conditions: solid resting on its base or solid resting on any one of its edges or edge of base or a generator or a slant edge. The next condition is a rule of visibility. Here this is an important parameter to be considered while drawing the projection of a solid. When drawing the orthographic view of an object, it is required to show some hidden details as invisible and are shown with help of a dashed lines. Even though we are drawing a projection of a 3D object, here we are going to draw the orthographic views of that object. So for that we are going to follow some rule of visibility. The first rule is all outlines of every view are visible. Hence the outlines of all the views are shown with the full or a continuous line. Let us take an example of this cube. Okay, here you can see all the outlines are visible, hence it is shown with a full or a continuous line. And then hidden lines are shown by a dashed lines. Here you can see there are 3 hidden edges and they are shown with the dashed lines. And one more thing is no 2 continuous line or no 2 dashed lines cross each other. Here you can see the 2 continuous line will never cross each other and no 2 dotted lines will never cross each other. Always there should be a dotted line crossing over a continuous line or a continuous line crossing over a dotted line. Okay, now let us see the initial position for different resting conditions. If any solid, either it may be a pyramid or a prism, is resting on one of its base edges, then that resting edge should be taken perpendicular to XY line. Here you can see, here AB is the resting edge which is taken perpendicular to the XY line. Okay, if it's a square pyramid or a prism, once again the resting edge, I have taken AB as a resting edge for all the problems. AB, the resting edge AB will be perpendicular to XY line. Here if you take a pentagon, then also AB will be perpendicular to XY line. If you take hexagon, then AB will be perpendicular to XY line. That is, a resting edge will always remain perpendicular to XY line, and that resting edge should be taken towards right, should be taken to the right of a polygon. Here you can see the initial position for a pentagonal pyramid. It is resting on one of its base edge on HP. So that edge should be taken perpendicular to XY line. Here I have taken BC as resting edge. You can name any way. Okay, you can name AB as a resting edge, or you can name BC as a resting edge. Any way you can name. But it's better to take a same letters as a resting edge for all the problems. Here by after if we take AB or BC as resting edge, then when we rotate, when we tilt this solid in the next second condition, then the entire solid will be resting on this particular edge BC. So always the resting edge should be taken towards right side and it should be perpendicular to XY line. Similarly, if the problem is resting on one of its corner, then that resting corner should be taken towards right of the, should be taken towards the right. And here you can see I have taken A as a resting corner. If it is a pentagonal, if we, either it may be a triangular pyramid or a triangular prism, the resting edge, the resting corner is taken towards the right. Similarly for square also I have taken the corner towards right. Similarly for pentagon also I have taken corner towards right, and similarly for hexagon I have taken a corner toward right. Here I have shown a template showing both front and top view. It's a triangular pyramid resting on one of its corner. So I have taken that resting corner towards the right side, and in the front view also it will be on the right. When you rotate or when you tilt this solid, when it leans towards right side, then it will be resting on this corner. Hence it is always better to take the resting corner or a resting edge towards the right. Now let us take a problem on a pyramid. I'm going to solve a square pyramid problem. A square pyramid, 40 mm side of base and 60 mm height, rests with one of its edges on HP. It's a problem resting on HP on one of its edges, and the axis is inclined at 30 degree to HP. Draw the projections of the pyramid when the edge on which the solid rests is inclined at 45 degrees to VP. Here the given data is, the type of a solid is a square pyramid. The side's length is given, it is 40 mm, the height is 60 mm, and it's resting on one of its edges. Here it's a square pyramid resting on one of its edge, means the initial position in the top it will be like this, right, resting on edge. So you can remember this template for all the problems. If it is resting on edge, then that resting edge should be taken towards the right side. Since the given problem is of a square pyramid, so the resting edge AB, the initial position will be like this, and then the axis is inclined at 30 degrees to HP, and the edge is inclined at 45 degrees to VP. The resting edge is inclined at 45 degrees to VP. Now let us solve the given problem. Okay, now let's start solving the given problem. The given problem is a square pyramid of sides 40 mm and axis length 60 mm, resting on HP on one of its base edges, and the axis is making an angle of 30 degree with HP, and the edge on which the pyramid rests is making an angle of 45 degree with VP. So initially we are going to place the pyramid on HP. Okay, the pyramid resting on HP with one of its base edges. So initially we are going to place the pyramid on HP, and we are going to take the front and top views. So this is the initial position. We are going to take the front view as well as, and we are going to take the top view of a given pyramid. So I'll start with drawing the front view. I'm going to take A and B as a resting edge, and that resting edge should be perpendicular to XY line. Always the resting edge, we are going to take it perpendicular to the XY line. So I'll start drawing. The resting edge AB. Let this be A, B, I am going to complete the front view, top view. This is A, B, C and D, and then I am going to mark the center of a base. This I am going to name it as O and O1, whereas O1 is the apex and O is the center of the base. Now this completes the top view. Now to get the front view, I am going to project all these points to the front view, that is to VP, and these projection lines should be a chain thin line, and the height of a given pyramid is 60 millimeter. I am going to draw the axis for 60 millimeter. So this is apex, I'm going to call it as O1 dash, and this is the center of the base, I'm going to call it as O dash, and then I'm going to connect apex with the base corners, and let this be A dash and B dash, and this will be C dash and D dash. Since the observer is here, now observer is able to see only the corners B and C. A and D is invisible, so I am going to keep A dash and D dash within the bracket. Similarly, in the top view, we are able to see all the slant edges. If you take this pyramid, we are looking from the top. This is the apex. Okay, this is the corners A, B, C and D. You are able to see all the slant edges, O to A, O to B, O to C, O to D. Hence I made all the slant edges darker, and only thing is apex O1 is visible, but O, the center of the base, is not visible, so I am going to keep it inside the bracket. So this completes the front and the top view in the initial position, and don't forget to do the dimensioning. The height of the axis is 60 millimeter, whereas the sides are of 30 millimeter. Sorry, I think it is 40 millimeter, 40 and 60. Follow proper dimensioning styles while doing the dimensioning. Now, in the next condition, the axis of the pyramid is making an angle of 30 degree with HP. So it means the pyramid initially it is in this position. Now the axis is making an angle of 30 degree with HP. So the pyramid is going to tilt like this. Okay, the axis, the imaginary line passing from the apex to the base, the center of the base, is making an angle of 30 degree with HP. So if the axis is making an angle of 30 degree with HP, the base will be making an angle of how much? It will be equal to 90 minus 30. Since base and axis are perpendicular to each other, if axis is making an angle of 30 degree, base will be making an angle of 60 degree. So here now I need to redraw this front view in such a way that the axis is making an angle of 30 degree with HP. So for that I am going to take a reference of base. Since base will be inclined at 60 degree, I am going to draw the base making an angle of 60 degree, and then I am going to reconstruct this first front view. So first I am going to draw the base. Base is making an angle of 60 degree. Since axis is inclined at 30. So first I am going to draw the base, and already we have considered A and B as a resting edge. So this is A dash and B dash. Now we transfer all the remaining points A dash, B dash to C dash, D dash, and then O dash. So this is D dash and C dash, and this is O dash. So first I am going to draw the axis which is perpendicular to the base and is having 60 millimeter. Now I am going to connect the slant edges with the apex. And this is O dash. After this I am going to draw the second top view. Further, to project all the points from the front view to top view. So this is point O1, and this is point A, B, C and D. And also project O. It is point O. Now we need to apply the rule of visibility. According to it, first we need to connect all the boundary points. I am going to connect D to C, then C to B, then B to O, O to A, and then A to D. Now I need to check for the invisible edges. Here, since the pyramid is resting on the edge A and B, and it is making an angle of how much? 30 degree with HP. So this is the present condition. So looking from the top, you are able to see the points, the corner D as well as C. You will not be able to solve C, A as well as B. So AB will be the invisible corners. So A and B should be joined with the dashed line. It indicates AB is invisible. And then you need to look into the slant edges. O to A is already connected, O to B is already connected. We need to check whether O to D and O to C is visible or invisible. Here, since those two slant edges are nearer to the observer, obviously those two will be clearly visible. So connect O to D and O to C with a dark line. So this completes the second top view, and also show the axis with a chain thin line. Now the next condition is the edge on which the the edge on which the pyramid rests, that is AD, is making an angle of 45 degree with VP. Now this edge should be making an angle of 45 degree with VP. So for that I am going to redraw this second top view in such a way that AB, the resting edge AB, should be making an angle of 45 degree with VP. So for that one, I am first going to draw a line inclined at 45 degrees to VP. Line inclined at 45 degree to VP. Now on this line I am going to redraw this second top view in such a way that AB is making an angle of 45 degrees. So for that, first I am going to mark A and B on this 45 degree line. I'll select point A here, and then measure A to B. I'm just redrawing the second top view in such a way that AB is inclined at 45 degree. And this be point B. Now with help of this A and B, I am going to get all the remaining points. I am going to take AB as a reference points and I am going to get the remaining points. Now I am going to measure A to D, and I am going to measure B to D, similarly I am going to measure A to C and B to C. Now I'm going to measure B to C. So now with the help of A and B as reference point and obtained D as well as C. Similarly get point O1, so this is point O1, and you can see O and O1 are on the same line. So for that one I am going to draw a line from O1 and I am going to measure O1 to O. so that I'm going to get point O also. Now you connect all the points with a straight line. A to B is a dashed line. O to D and O to C, and the axis with a chain thin line. Now to get the final view, I am going to project all these points from the top view to front view, from HP to VP. And before going to next step, just recheck whether we have got the same shape as we have obtained in the second top view. So now I'm going to project one by one. I'm going to project point A, and then B. So as soon as you project those points, you mark point A dash and B dash. Similarly, project point D and C. So this is for points D dash and C dash. Now project point O1, project O1. Similarly, project O, now you mark all these points. This is O1 dash, this is O dash. Now once again we need to apply the rule of visibility. According to it, I need to connect all the boundary points first. I am going to connect D to A, and then A to B, and then B to O, and then O to D. So first I have connected all the boundary points. Now observer will be here. Now to check the invisible corners, since observer is here, all the points nearer to the observer will be clearly visible. So point D, C and B are clearly visible to the observer. The farthest point to the observer is point A. So O to A will be invisible. Okay, the connecting, that is the slant edge O to A will be invisible. So one of the slant edge O to A is invisible. The remaining slant edges O to B is visible. Already it's in a boundary. O to D is visible. Once again it is a boundary. Now to C, now to check O to C. C is visible. Once again O to C will be a dark line. Since C is visible here, okay, now we'll check the base edges. C to D is near to the observer, so it is clearly visible. Similarly, BC is visible, and the remaining edge AB and AD are boundary points. They are already visible. So now you join O2 O1 each the chain thin line. So this is the required solution for the given problem.